Okay, now in the blockchain scenario, we are discussing Bitcoin, where we are discussing proof of work. In the proof of work, we want to make sure that the person who has done the maximum amount of work, he gets the maximum probability of being selected. And if the person who has done less work, have the less probability of being selected. So how do we make sure that? We give them work such a way that the work is fine, that everyone has to do some heavy amount of work. For example, if a mother says, come on, go to the restaurant or go to a shop and bring me this list of items, and whoever brings the amount quickest, the mother will say that yes, I will give you the first chocolate, or who is that is elected to be the one who will do something, maybe play or whatever. Now, in that particular scenario, mother has to make sure that the amount of time the person is taking is proportional to the amount of work they are doing. And how do they decide the work? Maybe depends upon the distance that they're doing, or the running they have to do, or the complexity, whatever they have to do. So if the mother has to decide amongst the three sons, whoever has done the maximum amount of work, then the distance is calculated, the amount of walking or driving or cycling, whatever they have to do is based upon that. So for a mother, this is for sure that the person has to go there and come back. There is no shortcut like that. So in a similar scenario, in the proof of work, every time somebody has to do some work to get there. And generally the work is to solve a mathematical puzzle. The puzzle is like that. Every block, we have seen that there is a hash of that particular block. And the hash of the block, let's say, is 256 bits. And let's suppose every bit stores or every digit stores something. So we will make sure that if the leading number of zeros are, let's say, 2, to get that leading number of zeros in the hash, whoever has done that and proposed the block first, that will have done the maximum amount of work. Now what does it mean by that? For example, if there is an input sample space of all the number of combinations of a block, then in the output, the first digit in the hash can be starting with 0 and can be starting with 1. As soon as we say that the first leading bit in the block, in the hash of that block is starting with 0, not with 1. So we are separating half of the input data. So we are negating half of the input data. If the block that you are creating is within this particular section, you cannot be selected as the leader. So our input size of the block becomes half. Then if I say the next bit is also 0, then what do I say that? So already I have 50% input size, so then it becomes again half. So I have remaining 25% input size. Why I am saying that? Because if I try one number, and how do I vary the numbers? The number is varied by changing the number used only once. So in the block we have a variable which stores number used only once. And when that number used only once is changed, the hash value also changes. And it's not a sequence in which it changes. It may be the fact that first number used only once, we tried 1, that the hash value is, let's say, 5000. Let's suppose if it is within four digits. Let's suppose the next number used only once is 2, it may be 5010. If the number used only once is 3, it may be 4023. If the nouns is 4, it may be 2000. Nouns is 5, the number may be 1000. Nouns is 6, the number may be 99. So there is no pattern in which the number used only once, if it is changed, it gets a different value as a pattern in the hash. So nobody can predict that based upon looking at the changes in the hash input, there is some number which will allow that hash value to have leading 2 zeros. Nothing. You have to try different combinations. And because you are trying different combinations, your probability of work will be, or your amount of work you have to do is the amount of combinations you can try in a given period of time. Hence, we say that whoever tries maximum number of those combinations, that has the highest chance of getting to propose a new block. Does it mean that always who does the maximum amount of work will get? The probability is high, but it may be possible that I try 2 combinations and one of them fits into that. Maybe possible. I try 10, fits into that. But generally the complexity is such a way that whoever tries out maximum number of combinations of nouns and other bits, they have the highest chance of proposing a new block. Proposing a new block means whatever block you are proposing, whose hash should have leading 2, 3, sometimes 16 zeros as well, and every zero is maybe stored not in bits but maybe in hexadecimal, where every bit represents some number. So even if it is stored in bits, so then whenever we are saying leading 16 zeros, that means that we are reducing the sample space of inputs to not only by 2, by 4, but by 2 raised to power 16. So if the size is, let's say, 20 million of inputs, we are reducing 20 million by 2 raised to power 16. That is the very small size of inputs that can be used to propose a valid hash. Yes, so that's how the proof of work algorithm works. So whoever tries that number use only once and other combinations, the sequence of data that you are using and other things that produces the output, then the blockchain verifies that this is the person who is elected, and the block that the person is proposing, that is considered to be the next block. That is how proof of work algorithm is used. So a lot of heavy computation is required to be done by every node, and that computation is almost good for nothing because you are trying different combinations. You are not doing anything meaningful job. That is the proof of work algorithm, which gives us a consensus in the blockchain. Thank you.